Hello, Assalamu alaikum. This is Salman Rahman. I'm from Group Horse Riders and I'm going to explain the milestone 5 and 6. So for the milestone 5 and 6 we did GCT version 2 and so actually for the milestone 5 and 6 there are two parts. One is the data path or data unit and the other is the control unit. So in the data unit, there are actually three main components. One is the input, the other is the subtractor, and the third one was the comparator. So if we go, what's the input component? So input component is actually something that we used for the multiplexing register. So which is of course made from a multiplexer with a 4-bit register. So if we see that for the multiplexer register, what we did is that depending on the value of the selector, so there will be either the output from this would be either A or D or B or E. So here actually if why we have to use this is because we know that for GCT version 2 so A can be changed, right? So because if let's say we put A as 9 and then B as 3, so for the next cycle A will be 6 and B will be 3, so which means A has to be uh, updated, right? So A has to be updated with the new value of A, right? So this is why we had to use input component. The second one was the subtractor. So the subtractor is something. So these are the subtractors, which is like A minus B and B minus A. And how does this work is depending on the value of from the comparator. So it's either if A is greater than B, if it's 1, then we'll have A minus B. If A is less than B, if we have 1, then we will do for the B minus A. So it's like we are using two subtractors here, depending which is greater, which of the two numbers are is greater. And the third one is comparator. It's just like comparing the both of the data to give output to the controller. So yes, so this is all for the data path. Okay, so the second part was controller. So the controller we actually had to make ASM chart, and from the ASM chart we got the state equations and the output equations, and from that output equations we used one hot encoding to get this the circuit. So this is our controller, which can control uh, based on the input from the data path and send another value or another uh, another loading, which will loading signal, which will use the data path to give the expected output. So yeah, so that's all, and this is how the integrated circuit looks like. The data path going from to the controller, and the value of controller going back to the data path, and we can see the output here. So this is the output waveform for the subtractor. So here we can see that given depending on the value, like I already mentioned earlier, depending on the value of A greater than B or A less than B, the subtractor works. So it's like A minus B, as you can see, it's here, and B here is unchanged. And for the second part, it's the same thing. It's unchanged. B is unchanged. A is subtracted, and for this one is this one minus this one, so this one is unchanged and this one changes. This is the output waveform for the input. So for the input, is as we already spoke that the selector, depending on the selector, the output is given either which one is it, the old X or old A, or the new updated A, or is it B or the updated B. So it depending on the if it was greater or lesser, like A is greater or A is less than B, it's subtractors, right? So it's like A is the new A is A minus B. So depending on that, the selector, we actually can get the new A or B as here. So as we can see that M and N is the output here. So for the first one, this is 0, so it has to be A is the output here. So it's, you can see that the A is outputted here. For the second, here is selector is 1, so D should be output here. So this is output. For this part, you can see that the selector is again it's 1. So from, if we see from B and E, which which output is given should be the E, right? Because it's 1. So here we can see that this is output is seen. Yeah, so that's pretty much all. So this is the waveform, output waveform of the controller. So the controller, once it's given start, so depending on the value from the comparator, it checks and it gives output to the data path, back to the data path. So as we see that for GCD version 2, we know that until A or B is equal to each other, the cycle, the controller will control until A or A is equals B. So as we can see here that for the input here was A greater than B, and then for this cycle it was A equals B, and then the other cycle was A less than B. But if you see the output here is for the first one, the controller sends an output as A greater than X greater or A greater, and for the second one, this one is given as A equals B. And you can see that for this part, for the last part where A is less than B was given, there is no output, which means as the controller gives output as A equals B, the system or the GCD or the output is already given, so there is no any more steps. So this is the output waveform for the data path. So we use two inputs as 5 and 2. So we know that if this is 5 and this is 2, so the second part will be this A is, so A is greater than 2, so this will be A minus B, which is 3, and B is still unchanged. And for the next cycle, if we compare, is still A is greater than B, so it's A minus B, so the new A is 1, and B is still stays unchanged, right? But here last one is B is less than A is less than B, so A stays the same when B is updated with B minus A. So here we can see it, and then at the final we can find that the output is 1 and 1, and the equal part is 1 is output. So for the final integration of control unit with data unit, when we integrate both of them, we actually find, once we put these values as X as 6 and then Y as 2. So when we do it, we know that we will have 6, and then this is 4, Y is unchanged, and then this is 2, Y is still unchanged. So this is equal and it stops. So we can see 6 and 2, and then the output is 2 and 2, given that the first bit here is the LSB on the left.